Hey everybody, here's the video notes for 3.2 and 3.3. I'll do some additional notes for each of those, but here's the video for both of them. First, a bit of review. We need to remember we're talking about rational numbers, so we're dealing quite a lot with fractions and we'll be dealing with some decimals. So for fractions, it's important to remember our numerator, denominator, and what a common denominator is. And so if we have a fraction 3 over 5, the term on the top of the fraction is our numerator, okay, or n for north. The denominator is the term on the bottom of the fraction, so that one right there, d for down, you can think about. And a common denominator is a term that two or more fractions have as their denominator. So if we had 3 over 5, and we also had 2 over 5, and we also had 7 over 5, they have a common denominator of 5. Okay, important to remember because when we get to adding and subtracting fractions, we need to have a common denominator to do that. So when using a number line, there are 4 basic rules. And there's some number line questions at the top of the textbook questions. So when adding a positive number, you move to the right. And I'm going to show some examples. When subtracting a positive number, you move to the left. When adding a negative number, you move to the left. And when subtracting a negative number, you move to the right. I like this little diagram because if you remember when you multiply and divide positive and negative numbers, so if you have a positive and you're timesing it, remember it's going to turn out being a positive. And if you have a negative and a positive, it's going to turn out negative. You have a negative or a positive and a negative, it's going to end up being negative. And if you have a negative and a negative, it's going to end up being positive. So you could think about that still, it almost applies, but now we're just talking about whether you're going right on the number line or left on the number line. So these are our left and these are our rights and a right. Okay, so I'll show you a few examples on the number line right here. So if we're adding a positive number, if we're at 3, you could think about a little person if you like. I don't know if that's helpful, but if the number, if you're adding, you look towards the positive and the number is positive, so you're going to walk forward. So they walk forward 2 and they end up at 5. Okay. Here we could think we've got our little person right here. Okay. They're subtracting, so they're going to be looking towards the negative. But the number 5 is positive, so they're going to be walking forward 1, 2, 3, 4, 5. And so they ended up at 3. 8 subtract 5 is 3. Okay, that makes sense. Next, our little person here is starting at 7. They are adding, so they are looking towards the positive, but the number is negative, so they're going to be jumping backwards. So they're going to go backwards 1, 2, 3, and they're going to end up at 4. Okay, 7 plus negative 3 is kind of like subtracting 3. And our last one, if we've got our little guy standing right here, and they're subtracting, so they're going to be looking towards the negative as if they're looking that way, but the number is negative, so they're going to end up jumping backwards to 6. Okay, so remember when you minus a negative, it's like adding a positive. So a 4 subtract negative 2 is actually like 4 plus positive 2, and you end up at 6. So I don't know if that's helpful, but there you have it. And so when adding or subtracting fractions, we need to have a common denominator. So that's the same number on the bottom of the fraction. So I'll do an example right here. We got 3 over 4 plus 1 over 2. So we need a common denominator. So we have to think, what is the first number that both 2 and 4 go into? Well, I know 4 is the first number that both of them go into. So we can change this fraction by multiplying the top and the bottom by the same number. So I'm going to multiply the top and the bottom by 2. So we end up with 3 over 4 plus 2 over 4. It's the same. It's still a half. It's still a half, but it's just in a different form. Now we can add the tops. 3 plus 2. It's going to be over the same denominator. and you get 5 over 4, or you can call it 1 and 1/4. And now for subtracting, we need to have the same number on the bottom as well. So let's go subtract. I'm just going to use our version from up here. Or it's adding, but it's a negative now, -half, -2 over 4. Now we can go 3 subtract 2 over 4, and we end up with 1 over 4. For our next one, to convert mixed numbers to improper fractions, we multiply the denominator, this one here, with the whole number, this big one right here, and then we add the top one, and it's all over that original denominator. So let's go. We go 5 times 2 plus 2. So 5 times 2 is 10, plus 2 is 12. That's still over the original denominator, so over 5. And let's convert our next one. We have 2 times 4. This is a negative. 2 times 4 is 8, plus 1 is 9, and it's over our original denominator. But now, in order to add these, we're going to need the same number on the bottom. So we need to ask ourselves, what's the first number that both 5 and 2 go into evenly? 2 doesn't go into 5, so we need to change both of these fractions. I know that 10 is the first number that both of them go into. So we're going to change both of these fractions so that they have 10 on the bottom. So 2 times 12 is 24 over 2 times 5 is 10. And that's adding negative. 5 times 9 is 45, and 2 times 5 is 10. And now we are adding a negative 45, so I'll show it like this, 24 plus negative 45 over 10. And we're going to end up with a negative number. It's going to be negative 21 over 10. And we can convert this if we want to a mixed number. How many times does 10 go into 21 without going over? It goes in twice with 1 left over 10. And let's not forget, this is a negative number because we subtracted more than we had. So we end up with negative 21 over 10, or negative 2 and 1/10. On to this next page. If I'm going too fast, just holler at me to pause, and I can pause it for a second. This question, it's the exact same question as up here, so maybe I'll just skip that. Just look up on the next page, and you'll see the answer to that one. This one, write the addition statement that the number line represents. I only put 1 there. So this is asking us to write basically an equation represented by this diagram. So if we look, we're starting. This is where we start. Usually they have a little line and they put an arrow to show the direction that we moved in. So you can imagine your little person starting here if you want. So they're starting at negative 1/2. And they are moving forward. So they're moving in towards plus, so it's going to be plus, and they're moving in a positive direction, moving forward, so that's going to be a positive 1 3/4. So, we can solve this if you'd like. It just asks us to write an addition statement, but let's solve it just for fun, okay? So, we need a common denominator if we're going to add these. So let's put negative 1 over 2 plus, let's convert this. 4 times 1 is 4, plus 3 is 7 over 4. Oh, actually, I don't need to solve it. My bad. It's already right there. So this is just 1 1/4. Okay, we can skip that. We did it, folks. Okay. The next one, we don't need to show it on a number line. I did make an example just to kind of demonstrate it. These ones I would honestly just put in your calculator, but I'll show you on the number line so we can estimate about where we think this is going to end up. So we have 9 and close to 9.8, okay, pretty close to 10, and we're going to subtract 13 and a bit. So let's start, I think I drew it right here. So we're starting right about here, our person. And we have, so it's 9.78 plus negative 13.33, I think. So we're going to be looking towards the positive because we're adding, but because this is a negative number, we're going to be walking backwards. So let's start with our 13. We're going to jump 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. We're going to end up there. And then we got to deal with our 0.33. So another little bit, about a third of the way. So we end up about there. So, my guess, we're going to end up between -3 and -4, maybe -3.5, close to there. But I know we got some additional numbers, so we can figure out what that is. But that is just to visualize it. You can see roughly where you're going to end up. But honestly, I would do this in my calculator. 9.78 plus 13.33, that's a negative, is going to end up with, there you go, negative 3.55. And our last one, we're going to need to take a few steps. We need to convert both of these into an improper fraction, and then we're going to have to find a common denominator. So let's do that. 5 times 3 plus 3, that's 15 plus 3 is 18 over 5. And that's going to be minus negative 2 times 5 is 10, plus 1 is 11 over 2. Now, to make these into the same denominator or common denominator, I need to times the top and the bottom by 2 here, and times the top and the bottom by 5 over here. We get 36 over 10 minus negative 55 over 10. And remember, when we are subtracting a negative, it's like adding a positive. So we've got 36. If, we were thinking our person is looking towards the negative over here, but then they're going to jump backwards. So they're going to end up actually going into more positive territory. So we can go 36 plus 55, which is going to give us, I think, 91 over 10. And then we can convert that to a mixed number. 10 goes into 91 9 times with 1 over 10 left over. Okay, I'll give you the textbook work that I want you to do. Thank you so much.